Good morning, everyone, and welcome to day 2 of Transformation Week. As you probably know by now, there are about 35 to 40 sessions going on this week. And if you want to find out about any of them, find out the schedule, just email events@mediacom.com. I personally want to thank Mediacom for organizing Transformation Week and for inviting me to speak today. Today's speech is about how AI algorithms work. And what this is meant to be is a way for you to start to develop an intuitive understanding for how artificial intelligence functions. In order to do that, you do not need to understand mathematics. You do not need to understand data science. You don't need to know the details of a neural network. It's really about building intuitive understanding. That's what we're working on today. As background, I run the Emodo Institute, which is a part of Emodo, which I'll get to in a moment. The Emodo Institute is a thought leadership organization that won the 2020 Ad Exchanger Award for Best Industry Commentary and Analysis. We try to change the industry conversation by demystifying complex subject areas, especially ones that are underreported and much more important than buzzwords. And they may be buzzwords, but they shouldn't be buzzwords. Artificial intelligence is certainly one that fits that criteria. 5G is another one, and data quality is another one. Data quality is a larger source of marketing waste today than viewability and fraud combined, and yet there's not nearly as much focus on it. We have a lot of content on data quality. We have a lot of content on 5G. With the recent launch of the iPhone 5G, it's really 5G's moment to shine, and it's time for marketers to take 5G really seriously. We have a lot of content about 5G, but today is about artificial intelligence. Just a little background on me. I have been with the company about 4 years. My background is largely in measurement at Nielsen and on the mobile carrier side as a marketer for 8 years at AT&T. In all of those roles, I was in very much a continual innovation type of a role. I've been in mobile media in some form for longer than I care to remember. I mentioned I work for Emodo. I'm going to take a moment first to just give background on Emodo. Emodo is a wholly owned subsidiary of Ericsson. Ericsson is the global telecommunications infrastructure provider that powers 40% of the world's mobile traffic. We are partners with carriers in over 140 countries, over 200 carriers. We provide equipment, we provide cell towers themselves, we provide network operations for carriers all over the globe, especially here in the UK. Emodo is the digital advertising arm of Ericsson. So our job is to take the data that is flowing through the pipes of the carriers around the world and leverage that data to benefit advertisers and marketers and make the marketing industry more transparent, more accurate, more trustworthy, and thus more effective. If you're not familiar with the Emodo brand, I won't take offense. It's probably because in the UK, we work very closely with our partner Mobsta, and I'm hoping that many of you are more familiar with the Mobsta brand. You can get a lot of Emodo's unique capabilities by working with Mobsta. Mobsta has been a partner of Mediacom's for over 5 years. We take great pride in our relationship with Mediacom. And if you want to find out more about what Emodo powers through Mobsta, please reach out to your Mobsta representative. So with that said, let's do some AI. So what we're going to do is we're going to go into detail on the mathematics of each one of these methodologies. I'm kidding, people. We are not going to do any of that. I promised you no mathematics and no methodology. And that's what you're going to get today. But the reality is I probably scared a lot of you guys right there. And that's because AI is confusing and can be scary. It's scary because in pop culture, we get a lot of negative views of cyborgs and bots. And we hear a lot of really famous people like Elon Musk issue warnings about the future of AI and how AI could take over the world. And it just sounds scary. AI is really complex. It's really easy to look at AI and think, I'll never get it. It is super complex. And you know what? Yeah, it is super complex. And I consider myself to be somebody who understands AI pretty well. And I don't get all the details. I couldn't tell you the intricate methodologies of convolutional neural networks. But I'm telling you, you don't need to know that. You don't need to be a data scientist or a mathematician to be really good at leveraging AI in marketing. And that's what we're going to teach you. There's a lot of blather around AI, a lot of directionless words, just words that are spoken by people that probably don't know much about AI, aimed at other people who probably don't know much about AI and are meaningless. There's a lot of buzz around AI. It's a buzzword today. And that is, as I mentioned earlier, really unfortunate. AI should not be a buzzword. It should be what I call a criteria. If you hear it thrown around, we shouldn't let it go in one ear and out the other. We should let it stick and think about it and really go deeper into what to make of somebody's claim about AI. And lastly, there's a lot of BS around AI. Sometimes it feels like every product in the world makes a claim to having AI in it as an ingredient. So what we're going to do is we're going to drive past all of this stuff, and we're going to make AI much simpler. First of all, I want to clear up confusion around the scary part of AI. So Elon Musk is famous for saying all these really worrisome things about the future of AI. And it plays on sort of a pop culture thing that we have, that the future is very bleak because machines are going to take over humanity. Elon Musk gave a quote in a podcast just a few weeks ago with Kara Swisher, the famous New York Times tech reporter, that I think really sums it up well, what he actually means when he talks about scary stuff about AI. AI does not need to hate us to destroy us. In a sense, if it decides that it needs to go in a particular direction and we are in the way, with no hard feelings, it would just roll over us. We would roll over an anthill that's in the way of a road. You don't hate ants, you're just building a road. That's really what we mean when we talk about concerns around the future of AI. It's not that machines one day are going to be so smart that they're going to collectively decide to take over the world and kill off humans. That's not really what people are worried about. What they're worried about is algorithms are taught to do one thing, which we will get into in more detail. And they're only taught to worry about things in the way that they're taught to worry about. And so, in theory, if you got into an automated taxi and that taxi was optimized only to get you to the airport as fast as possible with no other implications, then it's going to drive through red lights. It could run over people. Obviously, algorithms of automated taxis presumably are taught more responsibly to take other things into account. But in theory, AI on its own doesn't have a right or wrong. It doesn't have a judgment for what's right or wrong. It only does what it's taught. And so that's just something that we have to be responsible about in building and using AI. So with that said, what we're going to do is we're going to go into an analogy of using a dog and how a dog thinks, how a dog is trained, as a great way to understand how algorithms work. And I want you to imagine you're walking down a street and you see two dogs. One dog is sitting quietly, looking up at its owner, awaiting instructions. The other dog is totally unruly. It's chewing on stuff it shouldn't chew on. It's growling and barking. It's ignoring commands from its owner. So what's the thought that we have when we see these two dogs? How do we think of them as different from one another? If you're like me, what I would think is one dog is well trained and the other dog is not well trained. And that is a great way to think about artificial intelligence, because the reality is you train an algorithm very similarly to the way you train a dog. And if an algorithm is not performing, it's probably because the trainer didn't do a good job, not because the algorithm itself is bad. And so we're going to go into more depth into this analogy between a dog and an algorithm. And I hope by using the analogy of a dog that we're going to appeal to an intuitive understanding of algorithms, not get down into the weeds of math. So training an AI algorithm is a lot like training a dog. Now, it's not exactly like training a dog. So what I'm going to do is I'm going to start off with 3 differences between dogs and algorithms to just set the table. And then we will move into 6 things that are the same. First of all, dogs have instincts and algorithms don't have instincts. So when you get a dog comes pre-wired with some assumptions about what works. Like for example, if I bark, I will get my owner's attention. And a lot of times when we're training a dog, we're trying to train the dog to unlearn things that it came already assuming. Whereas with an algorithm is a true blank slate. It knows nothing, it does nothing until we introduce it to data. And so with an algorithm, you start off as a blank state and we have to a blank slate and we have to teach it something. Whereas a dog comes never a blank slate. And in some ways, we're trying to get it to be a blank slate by training it. The second difference is that dogs are always learning, whereas AI only learns when it's fed data. So even when we don't think that we're training the dog, we actually are training the dog. The dog is always learning and it's ingesting what it sees in its environment. Algorithms, if you're not feeding an algorithm data, it's not learning anything. And so it's our job to keep the algorithm modern and up to date. And it's hard work to keep it from being stagnant. And the third difference is that dogs choose their own goals and algorithms don't. So the way to train a dog is you figure out what that dog really values. It might be belly rubs, could be food or a bone. And then you convince the dog to do what you want in order to get what it wants. The algorithm is exactly the opposite. The algorithm doesn't have a goal of its own. You tell the algorithm what the goal is. Maybe the goal is conversions. Maybe the goal is completed video views. And it's the algorithm's job to tell you what to do in order to get that goal. So it's kind of the opposite. That said, there are 6 really similar things but between dogs and algorithms, and we're going to go through them one by one. The first one is a training set diversity rules out false patterns. So what this means is both algorithms and dogs, they're really good at picking up on patterns. Unfortunately, they're so good at picking up on patterns that they pick up on patterns that you don't intend to show and that may not actually be there. So for dogs, for example, if you are the only one to train your dog, then the dog is going to associate you with tricks. Therefore, if anybody else tries to get the dog to do something, the dog will ignore them because the pattern that it found is you. You don't intend for you to be the pattern. You intend for the command to be the pattern. But because the dog only saw you training it, it assumes that you're the only one who expects it to do anything. Same thing with algorithms. If you are building an algorithm to do facial recognition, for example, and the training data is largely Caucasian faces, then the algorithm is going to be really good at picking out Caucasian faces and not so good at picking out non-Caucasian faces. And so what this means in both cases is you need training set diversity. You need a training set that has every example of what could possibly happen so that the dog and the algorithm are able to rule out patterns that you don't intend to be there. The second training tip is both dogs and algorithms are only really good at one trick at a time. So a dog can be better at one particular thing than any human. Finding truffles in the forest is a great example, or finding illicit drugs in an airport. A dog can be great at one of those things. But if you take that dog that's world's best at finding truffles and try to get it to be good at finding drugs, you're basically starting from scratch. It's like a completely new process. And in AI, it's the same thing. An algorithm is good at one particular thing towards one particular outcome. If you try to teach an algorithm to be good at something else, even if it's tangentially related, one of my favorite terms in artificial intelligence happens. It's called catastrophic forgetting. Isn't that a great term? It basically means that when you take an algorithm that's good at something and you try to teach it something new, basically the first thing that happens is it completely forgets the first thing that it knew, and you're basically starting from scratch. So both dogs and algorithms are only good at one thing. So what that means is if you hear of an algorithm that's good at everything from cost per click to conversions to completed video views, ding, 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 alarm bell should ring, because algorithms just aren't good at a lot of things. They're good at one thing. The next one is algorithms need to be continually retrained. And the same thing is true for dogs. Dogs and algorithms can pick up on tiny, tiny differences that humans can't perceive. like on this right-hand side, two charts that over time they diverge just the tiniest little bit. A human being may not see that. Like in the programmatic universe, you may not personally see that the programmatic world, the inventory available in Valentine's Day week, if you're a flowers advertiser, differs slightly from the traffic available the week before Valentine's Day. But an algorithm can pick up on it. So what that means is it's required to continually retrain your algorithm. If you don't continually retrain your algorithm, an algorithm will quickly become stale. And so algorithms left to themselves become worse and worse and worse and worse and worse over time. And it's our job to maintain the quality of an algorithm. So it's one thing to want to get an algorithm to be better, and you can do that. But first, focus on keeping an algorithm the same, because naturally it will not do that. A dog is the same way. If you teach a dog to be good to your young toddler child, well, when that toddler is 5 years old, the training from when the toddler was a toddler is no longer relevant. You have to train your dog all over again to be nice to a 5-year-old kid. So, and you have to continually retrain a dog as the environment changes, even if you don't personally pick up on tiny changes, because the dog will. Fourth training tip: both dogs and algorithms need a lot of positive outcomes to learn how to get that positive outcome. So with a dog, for example, right now, I'm trying to train my dog not to bark at squirrels. So I can't do that by telling the dog when it barks at a squirrel, bad dog. What I have to do is tell the dog, good dog, every time the dog is not barking at a squirrel, which is challenging because you have to constantly pay attention to when the dog sees a squirrel and is not barking. It's very challenging. Algorithms exactly the same way. So if you're trying to optimize an algorithm to conversions, and a conversion is 1 out of every 1,000 or 1 out of every 10,000, then your average training data set just doesn't have enough conversions for the algorithm to draw great patterns. So you need a huge training data set with lots and lots and lots and lots of conversions so that the algorithm has a way to develop what those patterns are that drive those conversions. So remember, lots of positive outcomes. The fifth one is training data sets must be true and consistent. So what we mean by that is if a training information given to a dog or to an algorithm is not consistent, then the dog and the algorithm end up confused and unable to do anything. So if sometimes you're in a good mood and you reward your dog for sitting, and other times you're not in a good mood and you don't reward the dog for sitting, well, the dog is confused. Like, is sitting worth it? Doesn't know. An algorithm is exactly the same way. When you have a training data set for an algorithm, you have to make sure the training data set is consistent. And the best way to be consistent is to have your training data set be a truth set. You have to make sure the training data set is a truth set. If it's not a truth set, it's not going to be consistent. The algorithm will have trouble finding patterns. It won't be an effective algorithm. So one of the most important questions to ask when looking at an AI-based solution is, how do we know that the training data used to train the algorithm was accurate? The last training data set, and we touched on this at the beginning, is both the algorithm and the dog can be trained to do anything. You can take the cutest, smallest, most adorable little puppy and train that dog to attack. If it's a tiny puppy, maybe it won't be very effective at attacking, but you can get the dog to learn to attack. The dog doesn't know that attacking is bad and not attacking is good naturally. It learns what it's told to learn from its owner. An algorithm's exactly the same way. An algorithm can be just as good at spreading malware as it is at catching malware. So it all comes down to the trainer. What was the trainer's goals? What were the trainer's goals, and how effective was the trainer at accomplishing his or her goals? And so if you see an algorithm, just like you see a dog that's behaving badly, you think that dog is badly trained. It's really important to remember that when you see an algorithm either not being effective or doing something that you don't want, that's because it was trained that way or not trained well. So blame the trainer, not the algorithm. So we've talked through 6 ways that algorithms and dogs are similar. I hope that you walk out of that with a little bit more of an intuitive sense for how algorithms think. So what we're going to do is we're going to put that into action, and we're going to walk through a 9-step coming of age story of building an algorithm. How do you go from the beginning to the end of developing an AI program? And how do we take each of the 6 lessons that we just learned and see them as part of that process? So the first thing, never to be overlooked, is understand if AI is even necessary. Before we build an algorithm, we want to first make sure that it makes sense to build an algorithm. And there are 2 key questions that suggest whether an algorithm is necessary. Number 1, real time. Do you need decisions in real time? Because if you don't need decisions in real time, you may not need an algorithm. You may just be able to do analysis, check up against a deterministic database, and get a real answer. An algorithm is basically a guess, and you only need a guess if you need to know right now. Otherwise, you might have time to figure out something better than a guess. The second thing is, do you have an option other than guessing? So, for example, when you're segmenting users, when you're targeting them, do you have a deterministic database that you have time to check to see whether this user belongs in a certain segment? If you have that time and you have that deterministic data set and you're sure that the deterministic data set is true, then you probably don't want an algorithm. You probably want to go with the data that you actually know. Whereas if you don't have deterministic data and or you need to know right now and don't have time to check the deterministic data, then it's probably a great place for an algorithm. So real time and lack of alternatives. Those are the 2 things that suggest that you need an algorithm. If you do need an algorithm, then the most important step to take is you have to find that training data set. And I hope that one key conclusion you took out of this talk so far is that training data makes the algorithm. With the, it's garbage in, garbage out. So you have to find the right training data set. How do you know it's the right training data set? Number 1, it's consistent, which basically means it's accurate, it's true, it's a truth set. Number 2, it's diverse, so as to avoid bias. So you have lots of examples of every circumstance so that the algorithm is able to rule out patterns that are not really there or you don't intend to be there. And thirdly, thoroughness. You need to make sure you have tons and tons of positive outcomes, even for rare outcomes, so that your algorithm has the opportunity to develop those patterns and find those patterns. So if you know you need an algorithm and you've got the right training data set and you know that it's the right training data set, then you actually build the algorithm. And to do that, you take typically 80% of the training data and you have the computer look for patterns in the 80%. Then you have it test the patterns that it found against the other 20% of the training data. Because the other 20% of the training data, you know the actual truth for that 20%. So you use the algorithm to guess at the truth, and then you see whether the algorithm was right. If the algorithm was generally accurate in the 20% of the training data that was not used for the initial training, then the next step is you go out into the wild. I call this into the wild. So you point it out into the programmatic universe, for example, against bid requests in real time, and you use the algorithm in real time, and then you check back later to see, well, did I end up being accurate or did I drive better results? You could even just do it that way than I could have without the algorithm. And if you were successful in the wild, then you've got a functioning algorithm. But what's the last thing to remember? The last thing to remember is algorithms are constantly becoming worse because time changes, the world changes, and circumstances change in ways that even humans can't perceive. And thus the last step, never to be forgotten, is you have to continually feed training data to your algorithm to keep it fresh. We all want an algorithm to get better and better and better. And that is obviously the goal. But the first thing to do is just to make sure that your algorithm stays as effective as it originally was. And the only way to do that is to continually train. So hopefully this is a lesson in the complexity of building an AI program, but also the fact that developing an AI program is never done. Your work is never done. It's an ongoing, everlasting process to continually seek towards perfection. And always question what else you can be doing, what assumptions are wrong, what's wrong in my training data, what else can I be doing to drive improvement. It's an ever continuing process. So now that we've learned a lot about AI, we've learned how AI is built, what I thought we would do is go through a use case and talk about some of the ways that AI is being used right now in the global coronavirus fight. This list could be 100 items long, but I picked 5 for us to touch on. Number one is there's so much research being done. It's potentially unprecedented how much academic research is being done about coronavirus right now, all over the world. So much research that it's impossible for any human to go through all the research that's being done. So, what's the solution? AI. AI can go through all of these 8,000 plus research papers that have already been published about coronavirus and gather trends, gather patterns, find what we've learned as humanity about the battle to fight the coronavirus. There's actually a term for this about the fact that there's so much research that no human can benefit from it on their own, and it's called infodemic. I really love that term. Second example is vaccines. We all know that we're in a global push to find a vaccine for coronavirus. This process to develop a vaccine has been unprecedented in its scale and its speed. That is largely because of AI. AI allows scientists to jump multiple steps towards the beginning. And rather than just a test and learn approach of trying a bunch of different compounds to see what works, AI can help predict which compounds are likely to have an impact, to have a positive response from the human body, and then basically jump multiple steps to put those things into trial much more quickly. And that's why we have 179 vaccines in trial right now globally. That's a month or two old, that data actually. CAT scans. AI is helping to detect the virus from lung scans, from CT scans or CAT scans. Right here in London, there's a trial going on at Heathrow Airport of 20-second AI-driven COVID-19 tests. So these are not deterministic tests that are looking to see how much virus is in the body. They are tests that are looking really quickly at hints in the saliva that can help an algorithm predict the likelihood that there is coronavirus in the body. And so it's a whole different way to test. It'll never be 100% accurate. But if you can get really close to 100% accurate, if you can get really accurate, then it can help open up things like travel. And so, that's a trial that's going on right now. And then lastly, in Australia, I really get a kick out of this one. As summer is starting right now in Australia, there are AI-powered drones that are judging public space capacity. So you have drones flying over beaches, judging through video comprehension when the beach is at full capacity and what sort of capacity people are creating at that beach in terms of the space that they need to leave between each other. So, I mean, this is just 5. There could probably 100 things that I could put on this list. AI is an enormous part of the global global fight against coronavirus. But I thought it'd be fun to go through a few of those. So lastly, what I want to leave you with is if you found today interesting and you found this content to be valuable, this is actually a little small piece of a podcast that Emodo has. The podcast is called Five, F-I-V-E. It's available on Apple or Spotify or wherever you get your podcasts. We are on season 2 now. Season 1 actually won multiple awards. Season 1 was about 5G. So if you're interested on the impact of 5G on marketing, I highly encourage you to listen to season 1. Season 2 is about artificial intelligence. And in fact, episode 3, which is the most recent episode launched, is about the analogy between dogs and algorithms. So it's a chance to hear even more, including an interview with a world-renowned dog expert to understand the relationship between algorithms and dogs. So we've only got a minute left. We have just enough time to maybe touch on a question or two. So I'm not going to be able to get to all questions. If you do have questions, please email them to events@mediacom.com. And I will ensure that I will reach back out to you directly with an answer to your question. In the meantime, one question we're getting is, when I'm evaluating solutions, how do I know which claims are real and which are not? boy, this is probably a course unto itself. But a couple tips. Number one, I think don't think of buying an AI solution as much different from buying any other kind of solution. Put it through the same kind of tests that you would put through any solution. Like, how does this company prove to me that the ROI is positive on their solution, that they can drive better results? So it doesn't matter whether the AI, how the AI was built or what it does behind the scenes. What matters is that it improves my conversion rate by 43%, or whatever it might be. So I hope that's helpful. That's all we have a chance to get to today. Again, I really appreciate MediaCom for this opportunity, and I hope you found this presentation helpful, and enjoy the rest of the day.